So today we're going to talk about the 40-45-90 triangle and the 30-60-90 triangle. Now both of these triangles have special properties that make them easy to find all its sides using knowing their angles. So let's look at the first one. For problem number one, we have two triangles, both of which are 40-40, 45-45-90 triangles. Okay? By knowing that this side, okay, is 2 square root of 2, we also know the property. We know the hypotenuse is equal to the square root of 2 times s. So once we know what s is, we know what the hypotenuse is. So just a matter of plugging in x. X is equal to the square root of 2 times s, and we know that s is 2 square root of 2. So we perform the multiplication. You have to remember that whenever dealing with radicals, you multiply the insides together and leave the outsides outside, okay, which is equal to 4. So in this case, very simple process, x is equal to 4. Now for the second one, same principle applies. We know that the hypotenuse is equal to square root of 2 times s. And we know that s is equal to 9. So h is equal to 9 times the square root of 2, which makes this equal to 9 square root of 2. And that's the final answer. Now, in problem number 2, we need to figure out what the side is. Okay? And in this case, we need to figure out, use the variable x to do so. Okay? Once again, we're going to use the fact that there is a 45-45-90 triangle to figure out what that is. So we know the properties are the sides are s, and the hypotenuse is equal to the square root of 2 times s. So once we figure out what s is, we should have x. So the only equation that in this case works for us is 6 is equal to the square root of 2 times s. So we're going to write and solve that equation. 6 is equal to the square root of 2 times s. Since we're trying to find x, or s, in this case, we're going to divide both the top, the left and the right hand side by square root of 2. On one side it cancels out, on the other side we have 6 square root of 2. Now, technically that is the correct answer, but we never want to have a radical in the denominator. So we're going to multiply the top and the bottom by the square root of 2. Which means that on the bottom you're going to get 4, and on the top you're going to get 6 square root of 2. If we simplify that, 6 and 6 and 4 are divisible by 2. You're going to get 3 square root of 2 over 2. And if we go back to the original statement, we know that s is equal to x, so the correct answer is x is equal to 3 square root of 2 over 2. And that's your final answer. Now remember a few things. The relationship between the sides of a 45-45-90 triangle are always the same. Okay? You can always assume something like this is true. One side and the hypotenuse is always going to be s times the square root of 2. The important part there, the square root of 2. No matter what they give you, so long as you know that they're 45, 45, 90, you should always be able to figure out the relationship between them. So go ahead. What we're going to do now is you're going to try the practice problems. Okay? You're going to try to figure out what x and y are. For problem number 4, we have the second type of triangle, the 30, 60, 90 triangle. Now, I'm going to draw the 30, 60, 90 triangle here with its proper relationship. Okay? For the 30, 60, 90 triangle, you have to remember that always look for the shortest and longest side, because the shortest side is about half the longest side. Or if you want to think about it differently, the longest side, the hypotenuse, is about twice as big as the shortest side. And the middle side, the one in between them, is s times the square root of 3. Knowing that relationship, once you find the shortest and longest side, you should be able to find the length of all the sides. So, double check. We have a 30, 60, 90 triangle. Knowing that, we know the relationship between the longest, the middle, and the shortest side. So, it looks like the shortest side is D. Okay? The longest side is F. Okay, and the middle side is 5. What we're going to do now is try to figure out what those sides are. Okay? The only one that we can use in this case looks to be this one right here, because it's the only one that only has one variable. So we're going to go back and solve for x, just like we did in problem 2. We have the square root of 3 times s. We're going to divide both sides by the square root of 3. And you get that s is equal to 5 over the square root of 3. Now remember, we cannot have radicals in denominators, so we're going to multiply the top and the bottom by the square root of 3. Once simplified, you're going to get 5 square root of 3 over 3. Let me fix it. Once we figure out what S is, we can figure out what D is. So D is simply equal to S. Plug it in. Turns out that D is equal to 5 square root of 3 over 3. And f of x is simply 2 times S. That means that you're going to plug in whatever value of S you had before, and you're going to multiply it together. Simplified, it means that we have 10 square root of 3 over 3. So, the final answers are D is equal to 5 square root of 3 over 3, and f of x is equal to 10 square root of 3 over 3. For problem number 5, what we're going to do is combine the two triangles together to try to figure out what A, B, C, and D are. We're going to first begin with what seems to be the easiest, C. Now, I'm going to avoid using S in this case because it's just only going to confuse in between all the numbers. What I'm going to say is that C is equal to about half of 4 square root of 3 because it's the smallest side. So, once we figure that out, we figure out that C is equal to 2 square root of 3. Now, knowing C, we can figure out A, which is the vertical line going up here. Now, A, we know it has to be square root of 3 times C, because C is the shortest side. Since we know that, what we need to do is plug in C, and you're able to find what A is. Now, once we figured out A, we have also figured out D, because A and D, being this an isosceles triangle, are equal to each other. So we know that D is equal to 6. So let's mark it over here to see what we have. C is 2 square root of 3. A is equal to 6. D is equal to 6. Now we need to find B. Now B, if you remember correctly, you can pick A or D, whichever is fine, but it has to be the square root of 2 times A. In this case, I picked A, which means that when we plug it in, you're going to get 6 square root of 2. Okay, and that's B. Now we have effectively found all the sides of that triangle. Okay, all by using special triangles. So as a summary, just remember, there's two special triangles. The 30, 60, 90 triangle, which has a relationship between the smallest and the largest side of 1 to 2, and square root of 3 for the last one. Now there's also the 45, 45, 90 degree triangle, also on a right triangle, that has a similar relationship. The only difference is that we're not going to use a square root of 3, we're going to use a square root of 2 for the hypotenuse. So go ahead and try the practice problems on your own.